Alright, in this video we're going to take a look at working with some numerical data sets and talking about organizing and displaying data using some tables and graphs. So our first example here, given the weights below of 20 sampled players in a softball league, we need to create a frequency distribution. And it says use intervals with class width 25. Alright, so what I want to do is pay attention to the smallest data value. So it looks like we have a data value of 138, and that looks like the smallest one. So an interval with class width 25 means that we don't want to list all the possible weights out. What we want to do is categorize them into different intervals. So let's start. We'll make our table here with the first column being weight. Now I don't think I want to start with something like 138 or 131. I want to pick some round numbers. So if we're going to deal with a class width of 25, it might make sense to start at 125 and cover everything that's less than 150. So the way that our book does this, they use 125 up to 149, showing that the next class interval is going to start at 150. Now this interval width of 25, the way that you calculate that is you take one left endpoint and go to the next left endpoint. So 125 up to 150, that gives you your interval of width 25. So this one would go 150 up to 174. The next one would start at 175 up to 199. Then we'd have 200 up to 224. 225 to 249. And then let's see, what's the largest data value here? Looks like we have a 255, so we're going to need the 250 up to 274. Alright, so one way to do this is to put in a tally column, and then we'll put in our frequency column. Remember, what we need for a frequency distribution is simply the different values. Here we clump them into intervals and then their frequency. So I'm just going to go through. 138 would fall in the 125 to 149, then 171 would be in here, 170 also in there, 225 we're in this interval, 165, 143 would be in this first one, 150, 145, 183, 184, 180, 158, 147, 255, 169, 199, 158, 177, 205, and then finally 164. Alright, so once we have all of our values accounted for, let's see, the tallies are 4 here, so we got a frequency of 4. Then we got a frequency of 8, 5, 1, 1, 1. Now one thing that I always do, just to double check, make sure I counted everything, is let's add up these frequencies. 4 plus 8 plus 5 plus 1 plus 1 plus 1. We better get 20 out of this because we had 20 weights. So let's see, 4 plus 8 is 12, plus 5 is 17, and then 18, 19, 20. At least that's a partial check that we didn't double count or skip anything. So there's our frequency distribution. Alright, so now what we're going to do is create by hand a histogram based on this frequency distribution. So let's set up our y-axis and our x-axis. If we're doing a histogram, the only two acceptable labels for the y-axis would be frequency or relative frequency. Here we want the frequency. Now our frequency's only got up to 8, so the way I'm going to do this is let's make this 8, kind of cut that in half, that would be 4, cut that in half again, there's 2, there's 6, And here's my 1 unit tick marks. Alright, so now to label the X scale, this is going to be our weight in pounds. I'm just going to call this pounds. And let's throw a title up on top because oftentimes people forget title. Alright, so since the first class started at 125, I'm going to show this little break in the axis here because I don't want to start at 0. I want to start this at 125. And then I want to put all the other left endpoints, 150, 175, 200, 225, 250, and then finally the 275. Alright, so that first class, 125 to 150, we had a frequency of 4. Be helpful to get that in the right 125 to 150 interval. So now we got 125 to 150, frequency of 4. Alright, in the 150 to 175 or 174 on our table, we had a frequency of 8. Alright, 175 up to 199 or up to 200 there, we had the 5. And then the rest of them are easy, the rest of them are 1s. Now if you're doing a homework problem where they want you to do a graph, this would be perfectly fine. If it was a test, you would want to use a ruler and make sure your lines are much straighter than this. However, the major issues that we always want, we want to have the axes labeled, which we've got. We want to make sure we've got a title, which we have. And then one last final check, make sure your data is accurately shown. I'll check my frequencies, 4, 8, 5, 1, 1, 1. That looks good. So this would be our histogram. Alright, third example here, let's see, it wants a stem and leaf display. So sketch a stem and leaf plot for the data set below. The data set shows the ages of some randomly selected employees at a company. Okay, so let's get the title in here. Alright, the way a stem and leaf works is basically we're going to have this dividing line here, where on one side of it you typically write the tens digit or maybe the hundreds digit. In this place it would make sense to use the tens digit because we're dealing with ages. So let's see, we got ages that range from 19 up into the 60s, so I'm going to need a 1 for the 9, 2, 3, 4, 5, and 6. Right, the way this works is, let's start with the 19 because there's only one data value in the teens. To represent this 19, what I would do is take my ones digit and put that over to the right. This left side here, this would be your stem. The right side would be your leaf. Right, so it gets a little more interesting with the 20s because we have a bunch of different 20s. We want to put them in order though, so what I'm going to do is just kind of write them at the top. We got a 25. Let's see, we got a 23, 28, another 25, and then we got a 22. So the way that I'm going to write this is smallest one first. So we got the 22, which would mean a 2 over here. Right? The way we read that is here's the tens digit, here's the ones digit, so 22. Then just a little space and we'll put the 3 in there. Another little space, we'll put the first 5 for the 25, second 5, and then our last one there would be 28. All right, so we want to get that in order. Just going to erase these at the top. All right, let's do the same for the 30s. All right, so scan through. I'm going to look for the 30s here. We've got a 38. We got a 30. We got a 34. A 36. and then we got a second 36. So again, we'll put them in order, the 0 for the 30, then the 4, the 6, the 6, and the 8. Then I can go ahead and get rid of these. Alright, 40s. Looks like we have a 43, a 40, 41, and a 47. So we got our 0, 1, 3, 7. Alright, now let's go to the 50s. We got a 54, 51, 59, 50, and a 52. So it looks like we got a 0, 1, 2, 4, 9. And then last but not least, let's look at the 60s. Looks to me like we got a 64 and a 61. So 61, 64. Now this is almost the complete graph, but notice there's no key. So we got to show to a reader how we would interpret this. So here's one way to do it. One way to do it is off to the side, say that the stem is equal to the tens place, and the leaf is the ones place. Perfectly fine. Another way that you'll see that done is if you see something that just says something like key, and then in the key they just show you how to read one of the data values. So either way would be perfectly fine, but we want to use one or the other there to show a reader how to interpret our graph. Okay, so at the bottom here, let's suppose the first 10 people here were women and the remainder were men. We can construct a back-to-back, sometimes called a comparative stem and leaf, to separate and compare the ages by sex. Alright, so I'm going to erase this graph that we have here. And let's split this up. Let's put men and if we want to split it up by sex, then what we'll do is right down the middle here, we'll kind of have a small middle column. This is where our stems are going to go. So 1, 2, 3, 4, 5, and 6. Okay, so if it said the first 10 people here were women, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there are the women. They have the 19-year-old as a woman. Now we're going to go through the same thing. Let's search for the 20s in these first 10 numbers. So I'm getting a 23, a 25, I see another 25, and I see a 28. This is a smaller list, so I'm not writing them up top. I feel confident I can just scan through and put the ages in order. Alright, I'm only seeing one 30, that would be a 38. I see a 40 and a 43. Let's see, a 51 and a 54. And no 60s, so this would be it. Now we go to the men. You typically want to read left to right, smallest to largest, so for the men, we want to be a little bit careful. Now there's nobody in the teens over in these numbers for the men. I only see one in the 20s actually, I see a 22, so that's not a problem. I'm going to list the 30s out though, because I see a 30, a 34, a 36, and then another 36. So when I put these in order, I want to actually kind of either work from the biggest to smallest as I go right to left, or you can kind of plan it out and figure out how much room you need, put the 0, then the 4, then the 6, then the 6. Alright, so let's do the same thing with the 40s. I'm only seeing a 41 and a 47, so that's pretty easy. 47, 41. Alright, with the 50s, we got a, let's see, a 50 and a 59, and then, oops, also a 52. So 9, 2, 0, and both of the 60s are the men. So one of the things we use one of these comparative or back-to-back stem and leaves for is to compare our data sets very quickly. We notice the men's ages are slightly shifted to the higher end. Right? There are no men in the teens. There are a bunch of women in the 20s, only one man. Looks like the male ages are slightly shifted more towards the high end. So let's talk about stem and leaves versus histograms for a minute. The advantage of a stem and leaf is that you can actually know what the data values are. I can look at this and know that this woman was 38 years old, or that you have two men of 41 and 47. So the specific values are there. Whereas if we go back to the histogram, I know that 8 people were more than 150 pounds, or well, I should say 150 pounds or more, but less than 175. But I don't know if they were 150, 158, 169. We don't know what the specific data values are. So the advantage of the stem and leaf graph is that you know the raw scores. Advantage of the histogram is it's often not really feasible to make a stem and leaf for really large data sets, and oftentimes the simplicity of a histogram is preferred.